It began not with an explosion of light, but with a whisper in the data, a faint object streaking through the void faster than any comet born in our sun's cradle. When the Atlas survey first recorded it on July 1st, 2025, it seemed like just another wandering rock, a fragment of cosmic history crossing our sky. But as days turned into weeks, what we saw didn't match what we knew. Its path was too steep, its glow too unstable, its chemistry too alien. They called it 3I Atlas, the third confirmed interstellar visitor after Oumuamua and Borisov. NASA's initial report sounded calm, clinical, certain. A carbon-poor, CO2-rich body on a hyperbolic trajectory, no more mysterious than a comet passing through. But then came the light curves, erratic, inconsistent with any natural rotation. Spectra hinted at chemical depletion patterns that defied every model of formation. Polarimetric readings turned negative where they shouldn't. And that's when suspicion began to grow. Not from conspiracy theorists, but from scientists themselves. What if the data NASA released wasn't the full picture? What if the most important details, the ones that didn't fit the narrative, were quietly filtered out for further verification? Because something about 3I Atlas refuses to behave. Its coma ignited at nearly 6 astronomical units from the sun, too far for CO2 alone to explain. Its tail curves not away from the star, but toward it. Even its color profile changes with time, as though it's shedding more than ice. And beneath that quiet shimmer, something doesn't add up. When I first examined the raw photometric data from the Atlas telescope network in Chile, I noticed something that shouldn't have been there. A subtle flicker, not in brightness, but in polarization. At first, I assumed it was an artifact from atmospheric interference. But then identical irregularities appeared in simultaneous readings from Mauna Loa, Haleakala, and even independent amateur observatories tracking the object's path. The same deviation, the same time window, the same pattern. NASA's official data release, however, smoothed those fluctuations away. The light curve they presented to the public was clean, almost too clean, a textbook comet fading in and out as it approached perihelion. Yet the ground-based archives told a more chaotic story. The polarization dipped below negative 1.5%, something rarely seen even in dark, carbon-rich comets. 3I Atlas was supposed to be carbon chain depleted. The contradiction was undeniable. Then there was the question of activity. At 5.8 astronomical units, before even crossing Jupiter's orbit, the object began releasing a faint, extended coma dominated by CO2, with minimal traces of water vapor. Comets from our system don't behave that way. Water drives their awakening closer in, around 3 AU. The early outgassing of Atlas implied a volatile mixture alien to the sun's heat. And still, as NASA's public statements framed it, this was consistent with interstellar comet behavior. But it wasn't. Not with the negative polarization. Not with the anti-tail pointing toward the sun. Not with the erratic brightening every 11.3 hours that suggested unstable rotation or surface collapse. Even the James Webb Space Telescope's near-infrared readings were oddly truncated, missing frames in sequences that should have been continuous. Privately, some researchers whispered about data gaps, observation blocks marked as classified calibration tests. Others hinted that the information came too neatly filtered, as if someone had curated what the world was allowed to see. Maybe it was procedural caution, maybe not. Because what remained in the unfiltered datasets points toward an object neither comet nor asteroid, but something transitional, a fragment of an exoplanet's crust, or a volatile rich shard ejected during a cataclysm light years away. And if that's true, then 3I Atlas could carry within its dust the memory of another star system's history, the geological fingerprints of a world long gone, a relic crossing the sun's reach just once before disappearing forever. But if that's the case, why does so much of its recorded behavior remain redacted? Why does every new image come with more corrections than answers? Something about 3I Atlas isn't being fully told, and the deeper we look, the less the official narrative holds together. The first real fracture in NASA's version of events came not from inside the agency, but from the European Southern Observatory. In mid-August 2025, the VLT Sphere instrument captured polarized light readings that differed sharply from those in the NASA distributed dataset. Instead of a soft, comet-like scatter, Sphere recorded a distinctly negative polarization surge between 20 degrees and 25 degrees phase angle, a behavior no known comet nucleus has ever produced at that distance. That measurement, confirmed by secondary calibration, implied that 3I Atlas wasn't reflecting light like a diffuse snowball, but like a surface layered with ultra-fine, opaque dust, almost metallic in its scattering profile. When the findings were quietly submitted to the Planetary Science Journal, something unusual happened. The paper lingered in review for over a month. Then, when it finally appeared online, the most provocative graphs, the ones that showed those negative surges, were replaced by placeholders. No explanation, no erratum, just a digital silence where data should have been. The lead author, Dr. Hannah Lutz, later confirmed that external reviewers had requested clarifications of calibration methodology. But when other astronomers attempted to replicate her model using the archived raw data, access to the repository had been temporarily suspended for maintenance. That was when the whispers turned into questions. Could 3I Atlas be coated with a mineral crust? Perhaps carbonized silicates or iron-bearing dust hardened by cosmic radiation? Could its surface be a remnant of an exoplanetary core, compacted under a gravity it no longer knows? The CO2-rich composition fits with the idea of a body once buried deep beneath a frozen mantle, the kind you'd find if a world were stripped of its atmosphere and launched into interstellar space. Yet every attempt to probe deeper met with missing information. JWST's MIRI instrument, for instance, recorded thermal emissions consistent with a non-volatile surface, but that segment of the spectrum never appeared in the official release. Even the timestamps in NASA's online database showed gaps of up to 12 hours in key observation periods around September 9th, when the object's brightness unexpectedly surged. If this were just a technical issue, why remove polarization curves? Why redact spectra that showed nothing more dangerous than CO2 and dust? Unless perhaps those spectra hinted at compounds or reflective behaviors too anomalous to fit a simple cometary model. And as more private observatories compared notes, a disturbing consensus began to emerge, that the 3I Atlas data isn't being hidden because of what it lacks, but because of what it reveals. By early September 2025, the tone among astronomers had shifted from curiosity to quiet unease. The object that NASA had classified as a typical interstellar comet was now defying nearly every physical model that fit that description. Its trajectory remained unmistakably hyperbolic, roughly 37 miles per second relative to the Sun, yet subtle deviations appeared in its motion, as though small jets of outgassing were pushing it in unpredictable ways. But those thrust patterns didn't correspond to CO2 venting, or to any detected thermal peaks. Instead, they seemed random, or deliberate. At the same time, amateur astronomers noticed a strange periodic dimming of 3I Atlas every few days, resembling a rolling shadow, not rotation. Spectroscopic analysis from the Gemini North Observatory suggested that certain reflective patches on its surface appeared and disappeared, almost like sections of the body were peeling or fragmenting, revealing different materials underneath. That kind of variability would imply a layered structure, unlike any comet ever seen. NASA's official updates became briefer. Mentions of temporary fragmentation and surface instability replaced earlier confident language about a cohesive nucleus. What was once framed as a dusty traveler now seemed to be disintegrating into patterns no one could predict. The timing of these changes, however, coincided suspiciously with the first private reports of cyanide-bearing molecules detected in the coma. Faint traces that, while not dangerous, hinted at a chemistry that didn't match known interstellar ices. Meanwhile, observatories in Spain and Chile noticed that the anti-tail, the peculiar dust stream pointing toward the Sun, had grown sharper and narrower, its alignment changing by nearly 6 degrees in just 4 days. That kind of movement suggested not just sunlight pressure, but structural collapse, perhaps from within. And still, NASA's updates emphasized nominal behavior, avoiding any interpretation that could challenge their model. By late September, a handful of planetary scientists began drafting an open statement asking for full release of all JWST and VLT data related to 3I Atlas. Their demand was simple: transparency, because the inconsistencies were mounting and the silence was becoming too loud to ignore. When the statement leaked, the public finally took notice. Headlines began circulating, quiet ones at first, about withheld spectra, about unexplained orbital corrections, about dust behaving like metal foil. And then one researcher from Hawaii, speaking off record, said something that froze me. We stopped calling it a comet in our internal notes weeks ago. Whatever 3I Atlas was, it was no longer fitting inside the definitions we trusted. And the closer it drew to the Sun, the more it seemed to resist being understood. By early October, with 3I Atlas approaching its perihelion at roughly 1.4 astronomical units, the global astronomy community was operating in two parallel realities. In the public one, NASA and ESA continued to publish neatly summarized data, a harmless, if peculiar, interstellar comet with unusual outgassing behavior. But in the private communications between research teams, encrypted channels, shared spreadsheets, cross-checked timestamps, a more complex and unsettling picture emerged. Ground-based telescopes in South Africa and the Canary Islands recorded bursts of reflected light inconsistent with rotational brightness. They looked instead like brief mirror flashes, as though highly reflective fragments were breaking off, glinting for seconds, and then vanishing. When these readings were cross-matched with JWST's deep field imaging during the same window, several frames had been replaced by calibration blanks. And yet, the timestamps aligned perfectly. Something had been captured there, and then removed. At the same time, a series of photometric anomalies began spreading across the amateur network. Observers from different hemispheres reported that 3I Atlas's coma appeared directionally asymmetrical, with the sunward side exhibiting a soft violet hue. That coloration implies scattering by ultrafine particles smaller than 0.1 micron, something seen in industrial aerosols, not natural comet dust. Yet NASA's bulletins made no mention of it. Instead, the updates became even shorter, citing instrument noise and data harmonization delays. In the midst of that silence, a small team from the University of Arizona released a preprint suggesting that the object's density, inferred from non-gravitational acceleration, was too high for a porous ice body. Their calculations pointed to something nearly rock-like, perhaps metallic, with a reflective albedo far beyond that of carbon-depleted comets. Within days, the paper disappeared from the preprint server, replaced with a message stating that it had been withdrawn pending further analysis. I remember watching the live spectral feed the night before that retraction, when the tail's curvature inverted again, forming what looked like a translucent sheet cutting across space. It wasn't an explosion. It wasn't a breakup. It was more like a shedding, a deliberate release of surface material into the solar wind. The kind of event that should have made headlines, but didn't. And as the sun's glare grew stronger, ground observations became harder. We were losing the object just as it began revealing its most puzzling behavior. Yet for those of us watching the final data packet stream in, one thing had become clear. 3I Atlas wasn't following physics as we understood it. And whatever it was doing near perihelion, someone didn't want us to see it. On October 23rd, just a week before perihelion, the first true break in the silence came, not through NASA, but through a leak. A cache of archived infrared scans from JWST's MIRI instrument briefly appeared on a European mirror server before being pulled offline. The data lasted less than 40 minutes, but in that time, dozens of researchers downloaded it. When analyzed, the spectra revealed something extraordinary, between 4.1 and 4.5 microns. There was a deep absorption line inconsistent with CO2, methane, or cyanide. It resembled silicate resonance, but shifted, as though the atomic lattice was distorted by prolonged cosmic radiation, or alloyed with metallic inclusions. That feature shouldn't exist in a comet. It suggested processed material, something forged, not frozen, and yet the readings were unmistakable. Within hours, NASA's data portal listed the MIRI file series as corrupted due to calibration errors. The leak was traced, the mirror shut down, and the research community fell into a tense quiet. But the damage was done. The hidden signature had been seen, and it didn't match the story the public was being told. Meanwhile, 3I Atlas continued its approach, and a pattern began to emerge from the brightness oscillations. The intervals were too stable to be chaotic. Each surge occurred at near regular cycles of 11.27 hours. That consistency hinted at a controlled spin state, either a balanced tumbling motion or something more complex, perhaps involving mass redistribution. The idea that this object was once part of a larger structure, a moonlet or planetary fragment, was no longer a fringe hypothesis. When the comet passed inside 1.6 AU, new images from the VLT showed a halo of micron-sized debris expanding radially, forming what appeared to be a temporary disk. The light scattered within that disk was polarized in a way that mimicked metallic reflection, negative at small angles, positive at high ones. Every comet we know behaves the opposite. At this point, A handful of independent researchers, myself included, began compiling the fragments, the missing spectra, the infrared anomalies, the truncated polarization data, into a unified model. The picture that formed wasn't of a comet at all, but of an interstellar remnant, perhaps the crust of a world shattered billions of years ago, now passing through our solar system as a silent messenger. If true, this would rewrite how we understand interstellar debris and force us to question why the agencies that know this best seem so determined to keep it contained. Because as 3I Atlas neared the sun, every instrument turned to it began going dark. And that was when the real silence began. October 30th, perihelion. For a few fleeting hours, 3I Atlas was closer to the sun than Earth itself, and for that brief moment, the universe seemed to hold its breath. Observatories across the world, from Chile to Japan, had been preparing for this alignment. But when the moment arrived, most of the telescopes pointed toward its expected position saw nothing. No trace, no light curve, just a hollow patch in the solar background, as though the object had dissolved into sunlight itself. Then, minutes later, a faint echo appeared on the solar and heliospheric observatory feed, a shimmer like a dust shell expanding outward. But when the frames were stacked, something impossible emerged. The shell wasn't symmetrical. Instead, it formed a narrow, angular spread, almost planar, reflecting light along a razor-thin edge. It looked less like an explosion and more like an unfolding. NASA's press briefing that evening described it as fragmentation under thermal stress. But thermal stress doesn't create geometry. It doesn't generate straight-line reflectivity or a structured halo pattern that remains stable for hours. Instruments in Spain captured a polarized beam cutting across the dust plume, a feature never seen in any cometary disintegration. The spectral ratios suggested extremely fine particulate matter, high in iron and carbon, but also containing traces of titanium, an element that hinted at planetary differentiation, not primordial ice. Within 48 hours, 3I Atlas was gone. Its hyperbolic trail continued outward, a faint streak on its way back to interstellar space. But what it left behind was stranger than its arrival. A thin disk of particulate residue lingering near the ecliptic plane, shimmering faintly in the infrared for several days before fading entirely. We called it debris. NASA called it transient reflectivity. But many of us saw it for what it might truly be, a glimpse of an alien world's remains, material that had once known gravity, atmosphere, perhaps even oceans. It wasn't proof of anything alive, but it was evidence of something once formed. And as the data vanished from official repositories, the story faded from the headlines. The agency declared the object dispersed, its study complete. But astronomers continued to whisper, to model, to speculate. Because deep in those few surviving datasets, there are patterns, faint alignments and repeating reflective angles that look eerily intentional. Perhaps coincidence, perhaps not. Whatever 3I Atlas was, it didn't die. It merely disappeared, and left us with a riddle that science hasn't yet dared to name. In the silence that followed, as 3I Atlas vanished beyond the reach of our telescopes, I found myself replaying every dataset, every filtered frame, every vanished record. It was more than a comet, less than a world, something caught in between, a fragment of a story that didn't belong to us. NASA closed its reports. The European observatories archived their files. But those of us who saw the inconsistencies, who heard the quiet hesitations in the official explanations, were left with a question that can't be unasked. What if this wasn't just a visitor, but evidence? Evidence that worlds beyond our own die and scatter just as we might one day. That cosmic debris can bear traces of processes, materials, even histories we can't yet categorize. And that sometimes truth doesn't vanish because it's wrong, but because it's too large to fit within our systems of certainty. When I think of 3I Atlas now, I don't imagine the comet they wanted us to see. I imagine the silence it left behind. The blank spaces in the records, the gaps between numbers, the missing frames where something extraordinary might have been. We may never know what it truly was, but its passing reminded us that the universe keeps its most revealing truths just beyond our grasp, until we dare to look without permission. Do you believe we were told everything about 3I Atlas, or that its mystery was quietly buried in the data it left behind? Tell me below.